So good morning, everyone. Thanks for joining. Today, I think we have lots of participants. Um, so uh, just uh, just as a quick agenda, we have a 30 minutes presentation, and then we'll do a quick product demo on the forecast spread, and we'll open the forum for Q&As. So that is what we are going to do. So as Asangi said, during the first 45 minutes, that's during the presentation and during the demo. If you have any questions, please type them in. We'll try to answer them as much as possible during that time itself. Um, but at the end of the first 45 minutes during the quick Q&A, we'll if you have any questions, please raise your hand, and and I think Asangi will unmute you so you can ask that question. So that is how we are going to do it. And please ask questions. Please keep it chatty, right? Let's make it as informal as possible, right? Let's try to make it as interactive as possible. So that's the plan. I'll switch off my video to save a little bit of bandwidth. Okay, I'm going to share my screen. I think my screen is already shared. Hope everyone can see my screen. So what we are going to do is we are going to start with a very, very quick survey. We are going to use this cool product called Menti. So Asangi will just post a link right now on the chat. If you can just click on that. So I think you can see my screen, so you can see the answers come in real time. So this quick survey tool is called Menti. If you go to www.menti.com, you can actually do real-time surveys. It's a pretty cool product. You might want to try it one of these days. Yeah, I think out of about 20 respondents, right, almost 90% of them are forecasting right now. I think I'll move to the next question. So this is an open-ended question, so you can just type in. And we'll see a word cloud. So demand forecasting seems to be the most common use case here. All right, so I think demand forecasting seems to be the one which is mostly most common use case for forecasting, at least among this group of people. Uh, uh, since this seems to be a fun exercise, let's do two other questions maybe, and maybe Asangi can share another quick link for us to complete this survey. So there will be another link on the chat. If you can just go on to that one, that'll be great. Okay, how do you forecast? Excel. Okay, consensus. I think discussion, consensus, I think probably they're similar. So in terms of tools, what I see is CR, Power BI, Python. Of course, Excel basically seems to be ruling the forecasting world. Okay, I think it's pretty clear. I think we, as in terms of tools, we see Excel, SAP, we see Power BI, which is uh, quite popular, I guess. I can see a little bit of Python, and there seems to be lots of consensus discussion based forecasting as well. One last question. What are your concerns and challenges related to forecasting? Accuracy. Okay. Yeah, it's all about accuracy, it seems. Just a small misspelling there. Yeah, data consolidation. Yeah, that seems to be a good one. Yeah. Time consuming. So basically, we are talking about, I think accuracy is right on top of everyone's mind, obviously, right? And I think the other concerns are around getting the data, right? So there are data-related concerns, there's time-related concerns. Multiple variables. Okay, that's a good one. Yeah, I think multiple variables seems to be picking up the pace because real world accuracy. I think it's a good point, right? So sometimes when we forecast, right, when we back test it, the results are good, right? But when it's applied to the real world, right, that seems to be right an issue. So I think that's a good one. Okay, so let's move on, guys. So I think just to summarize, I think more than 90% of the people in this forum are actually obviously forecasting, right? Um, Let me just switch. Yeah, just to summarize, I think 90% of the people in this forum are obviously forecasting. What do they forecast? Mainly demand, sales, right? Those are the two big things that lots of people seems to be forecasting. I saw churn, I think, as a response to a different question, but probably that's something else that they're trying to forecast as well. Um, and in terms of the tools, right? I think Excel came up very strongly, and the other tools that that the forum talked about were things like Power BI, SAP, and a little bit of Python. And there was some consensus discussion based forecasting as well. And finally, in terms of the challenges, right, accuracy was obviously was the biggest concern and the challenge that I think everyone had. Apart from that, inputting data that came out as a challenge. Um, Data and data quality, right, and and time came out as a challenge. Uh, uh, Multiple variables, right? That complexity came out as a challenge, right? So I think that provides us, right, a very good springboard to start this discussion. So this is what we are going to talk about in this quick presentation. Um, so I'm going to talk about why are we reluctant to rely upon forecasting. I think we probably have answers, right? Because we took from our survey uh, to this question. Uh, I'm going to talk about accuracy as well as the scale, right? And I think it's a paradox. I'll talk more about that, and I'll talk about some critical questions that you should be asking yourself before you start forecasting, and I'll be talking about how to evaluate forecast, and we'll basically conclude with a very quick product demo, a very quick one of Forecast Squared, which is the product developed by Linear. So why are we reluctant to use forecasting, right? I think first and foremost, lots of people have a concern about the accuracy, right? I think it's very clear even from the answers that we got, right? So accuracy seems to be a concern, and as a result of it, people are reluctant to use forecasting, right? The other reason, I think I'll talk about the third reason, right? We call it low agility, right? Which basically it corresponds to the time it takes to get a forecast, right? So time, that's also bit of issue. And since it takes a long time, right? What happens is your forecast, most of the times it's outdated, right? So the business has moved on. The market conditions are different, right? I mean, we know these days, right? The market conditions can change quite dramatically, almost overnight, right? But somehow you're stuck with some old forecast that you did some time back. So agility is an issue. Granularity is another big issue, right? Because lots of people, right? What we have is probably a very high level forecast, right? So we have a national level forecast, right? And probably we have a category level forecast or a brand level forecast, right? But we don't go beyond that. But really, for you to use the forecast, maybe you need to have forecasting done at a lower granularity, right? Maybe we need to do it at the sales region. Maybe we need to do it even at the SKU level. Maybe you need to do it even at the distributor level or even at the retailer level, right? But you never go into that kind of granularity. And as a result of it, right, the forecast that you have, it's not that useful, right? So these are the three main reasons, right, why even the big enterprises, not just in Sri Lanka, but even globally, right, are sort of very reluctant to use forecasting, right? And we call it one of the biggest, the big enterprise secret about forecasting, right? People have these concerns, and as a result of it, they are actually rarely used, right? Even though all of us talk about forecasting all the time. So as I said, if there are questions, please post it on chat. I'll try to answer them as much as possible during the presentation itself. So let's keep it chatty. Okay, so what leads to low accuracy, right? I think one of the main reasons is the predictive effect, right? Now, this also came up, right? Multiple variables can impact your forecasting. Usually when we forecast, right, we look at historical trend and seasonality, right? And that is what lots of forecasting methodologies, right, look at, right? If you look at something like moving average, right, as an example, it'll just look at the historical trend, right? If you do something slightly more complicated, I won't call it complicated, but maybe slightly more advanced, right? Maybe if you use something like REMA or something like that, or if you use some kind of a smoothing technique, it'll consider trend and seasonality, right? But what happens most of the time is there are other factors in play, right? So as an example here, I've highlighted this point, right? So you can clearly see a trend, right? But all of a sudden, right, what is this point, right? Now, this point could be due to, right, maybe a very, very good, successful TV campaign, right? It could be due to that, right? So unless we bring this information into our forecasting framework, we will never be able to forecast accurately, right? So the predictor effect is one of the biggest things, right, that actually needs to be considered in forecasting, but typically it's ignored. And that is one of the main reasons why forecasting does not have that kind of accuracy, right? Um, and this is one of the main reasons why the forecast and the real actual data, right, can be different, right? Because in the real world, right, you might decide to do something with your marketing, right? You might decide to, slash your marketing budget by 20%, right? And now all of a sudden, the historical trend and seasonality, right, just cannot capture that impact unless marketing spend is part of your forecast. So let's say in a very, very, in demand forecasting scenario, right, I actually anticipated demand forecasting to be the most common use case. So I gave some predictors, right, for that use case. So we should typically consider factors like this: price, right, even weather, right? Some maybe macroeconomic factors like inflation can have an impact, right? What competitor do, right? Right. Are they spending on marketing, right? That can have an impact on your forecast, right? Or your demand, obviously. Marketing spend, holidays, competitor pricing, right? Uh, the below the line activities, right? Or the distribution related parameters, right? How many retailers that you're reaching out to, right? All of these factors can impact the forecast, or can impact the demand. So it makes sense to have all of that into your forecasting framework. So that is one of the main reasons why accuracy can be low. So predictive effect is one thing. The other thing is the modeling effect, the techniques that you're using to forecast. So as I said, most of the basic techniques do not capture this predictive effect. So that's one problem, right? If you look at moving averages over REMAs, they don't capture the predictive effect. So technically speaking, we call them univariate models or algorithms. So they cannot capture predictors. That's one problem. The other problem is, even if you look at some of the most sophisticated algorithms, right? The nature of the problem is usually there is no single model that can perform well under all circumstances. As an example, let's say you want to get your forecast done by region. Now, it is very, very likely that each region will have different behavior, and as a result of it, it's very, very likely that the best model for each region is different. So this is one of the biggest problems. Even if you use a little bit more sophisticated model, that actually doesn't mean that that same model can be applied into all of your forecasts. So that is one of the big defects, big issues. So you pretty much have to custom build or custom train these forecast models. So just to mention some names, right? So all of these, what I've mentioned here, are the multivariate models where you can actually capture the predictor effect. So some examples could be something like a Remax, right? A REMA is a univariate model. A Remax is where you can bring in some external predictors. That's denoted by this X at the very end. So it's like a REMA plus X. You can use very, very popular machine learning, tree-based machine learning algorithms, or like random forest and XGBoost. You can basically have you can adopt them into this time series sort of data. and you can use them. There are some neural network-based time series forecasting algorithms. Right? LSTM is the most popular one. It's called long short-term memory. And there are some third-party models. Now, some of these models are somewhat popular these days. As an example, in 2019, Facebook basically published their internal forecasting algorithm. It's called Facebook Prophet. So some of these things are available as well. So all of these things are multivariate algorithms. But as I said, it's very, very unlikely that one of these will outperform all of the others in all circumstances. I think that's the trick there. So that actually that's a very, very challenging situation, right? Because different forecasts, right, or different algorithms outperform each other in different situations. So, which means we have to custom build, right? Each forecast needs to be custom built or custom trained. Now that's a big challenge. So just to summarize what we talked about, right? So this forecasting problem seems to be hard, right? So it needs lots of skills, right? So we talked about the predictive effect, which means we need to bring in multivariate algorithms, right? Even when we bring in multivariate algorithms, it takes time, right, to build models. So if you want to build 10 forecast models, it takes a long time, right? So yeah, I think it's similar to, mountain climbing, right? You need a set of very, very specialized skills, right? Not all of us can, climb mountains. But even if you have those skills, right, it takes time, right? Even for the most skilled, it takes time, right? So basically, what that means is you cannot build lots of forecasts, right? Unless you have an army of people, right? Army of very, very skilled data scientists who are skilled in forecasting, you can't do forecasting at scale, right? So what basically happens is, this is the paradox that I talked at the very, very beginning, right? What basically happens is either you have few good models, right? Because it is difficult, it takes time, so you can only do few. So either you have few very good models, or on the other hand, the other option is you use a basic tool like Excel, and you basically forecast at scale, right? If you need 50 or 100 forecasts, you use Excel and get it done. But Excel forecasting obviously will have accuracy related issue due to all the factors that I mentioned. So that's the scale and accuracy paradox, right? So you can have few good models, right? Or you can have a lot of basic models, right? And it looks like we have to make a decision between the two, right? So this is the accuracy scale paradox I was trying to explain in the very beginning. So I'll take a small pause at this time, and I'll just check the chat to see if there are any questions. Okay, I think we can move on. Right. So let's talk about these things. Might actually look like very, very simple things, but when we look at forecasting, I think we see that that sometimes some basic mistakes are made. So the four critical questions you should ask yourself before you start forecasting, right? The first question is, what is the right time interval, right? What we mean by time interval is you can do your forecast on daily basis, weekly basis, monthly basis. So that decision, right? What is the right frequency or what is the right time interval for forecasting? What is the right forecasting horizon? Which means how long into the future that you need your forecasting. Can it be 12 months or can you live with a 6 months time interval? That also needs to be answered before we start forecasting. What is the right forecasting granularity, right? We touched upon this granularity or the scale problem, right? Can it be at the national level or does it have to be at the regional level? Or is it distributor level? Is it at the retailer level, right? As an example. What is the right forecasting unit, right? So that is another question that we need to answer. So let's just take an example right here, right? And see how we can answer these questions. Let's say we are going to use forecasting to plan raw material purchases, and let's say that we are in the beer manufacturing industry. So let's say a raw material could be something like barley or maybe hops or something like that, which needs to be imported. And typically it takes 2 to 3 months. Now, if we want to decide on the forecasting interval, right, or the ordering, forecasting frequency, right, we have to look at the typical ordering frequency. So if the typical ordering frequency, right, is monthly, the forecasting interval has to be at least monthly. So you cannot have forecasting a quarterly forecasting frequency, right? That means you will have a forecast for the next 3 months and the next 3 months, so on and so forth. You cannot have that kind of forecast and do monthly ordering, right? So the ordering frequency and the forecasting frequency actually goes hand in hand. Forecasting horizon actually it depends a lot on the lead time in this example. So if the lead time to get your raw material is about 3 months, right, you need your forecasting horizon at least to be 4 months, right? So that's quite obvious, right? So in this particular example, the forecasting horizon has to be at least 4 months. What is the forecasting granularity? In this example, it's a raw material ordering example, which means we need to know the total demand for this or the total consumption of this raw material. So if we can just do a national level forecasting model for the consumption of the raw material, that should be enough. So the granularity should be at the national level. So the point that I'm trying to make is actually this depends on the question that you're trying to answer. It depends on the use case that you're trying to solve. So in this particular use case, it turns out to be national level forecasting would be sufficient. Now, forecasting unit. Now, again, this depends on what you're trying to forecast. So let's say as an example, if you want to forecast, let's say your raw material could be a certain label, right? Now, in this particular example, right, bigger bottles can have a certain type of label, smaller bottles can have some other type of label. So if you're ordering labels, let's say as an example, you might want to do forecast. You will have to do forecasting at the SKU level. But if this particular raw material, right, if it does not depend on the SKU, and let's say that, right, this is a very generic raw material, like some type of hop that you use for lager beer as an example. We can forecast the total volume of lager, right? That should be sufficient. So it depends on the use case, right? So, but it's very important that these 4 questions are answered before we start on any forecasting exercise. So that's when If not, I've seen many times that after lots of time and effort, the forecast becomes unusable due to these reasons. Right. So I've been asked a question: are there any hybrid models? Um, so the question is related to since there is no clear winner, right? Can models can be combined. So that is what typically AutoML does, right? AutoML is automatic machine learning. Um, and these algorithms, basically AutoML algorithms, what they do is they basically uh, test out a series of competing algorithms or candidate algorithms, and depending on the situation, it tries to select the best one. So there are so that is where we need to build an AutoML layer on top of the standard forecasting algorithms, so we can basically select the best one automatically depending on the problem. So the product that we have built is an algorithm like that, where we consider about 2,000 different candidate algorithms and automatically tries to select the best one. And there are a few other products like that in the market, right? So these are very sort of upcoming area in forecasting, where people use AutoML into forecasting. So I think I'll move on. I think since everyone talked about accuracy, let me just talk, maybe spend 2-3 minutes on this accuracy question. So I think everyone knows this, right? So you have an actual number, you have a forecasted number, and you can just calculate the actual. You can just get the deviation, right? So here the deviation is right 80 minus 90, right? We take the absolute value of that, and we take it as a as a fraction of the actual number, right? So we can basically 1 minus of that, right, will be the accuracy. I think one important point that we need to realize here is it can actually move from 100% to negative infinity, right? I think don't be surprised if you calculate this accuracy figure like this, and if you get if you end up getting a negative number, it can actually go all the way up to negative infinity. But the maximum can be only 100, right? So you can imagine why it can take negative numbers, right? When your deviation is greater than the actual, right? So then once you divide that deviation from actual, you'll get a number which is greater than 1. So 1 minus a number greater than 1 will be a negative number, right? So that's how it can actually go all the way up to negative infinity. This is the very standard way of calculating the accuracy. I call this deviation-based accuracy. Now we can extend that example, right? So maybe you have done a weekly forecast, right? So for each week, right, you will have the actual number and the forecast number. And for each week, then you will have an accuracy figure. And we can calculate sort of an average weekly accuracy, right, using this, right? And typically in situations like this, it makes sense to take a weighted average. And so that's another way of summarizing the accuracy, right? So we can calculate these individual accuracies for each week, and then we can take a weight based on maybe the actuals, right? And we'll get a weighted average weekly accuracy in this example. Alternatively, what we can do is, right, we can sort of calculate the overall accuracy across these 5 weeks, right, which is quite straightforward. We get the total actuals and total forecast, right, and basically calculate our earlier mentioned accuracy figure based on these two numbers, 352 and 334. That will give you an overall accuracy, right? So typically, obviously, overall accuracy can be higher than the average accuracies because the pluses and minuses get cancelled off here, right? So you can get a high accuracy. So these things, I think it's very, very important, right, to realize at what level we need to consider the accuracy, right? Maybe if the use case is right, maybe we don't have a use case for weekly accuracy. Maybe the use case is really for this overall accuracy, right? So if that is the case, the accuracy needs to be calculated at that level. I think I'll skip this one, right? Just in the interest of time. One last point I want to make is, right, it always is a good idea to compare your accuracy with a very, very basic model like a moving average. So let's say you have a forecast that you have got, or maybe by using maybe Excel or any other tool that you're using, but get another forecast using very, very simple method like moving average, or maybe even simple average, and then then obtain the accuracy for the moving average as well, or the simple average. Then keep it as a benchmark, right? And then compare the accuracy of your forecast model with that benchmark. If not, we'll always have the problem, right, where we think 90% is good, 60% is bad, right? But maybe sometimes the moving average can also might end up giving you 90%, right? And moving average, right? So your 9% forecast may not be that good, but your 60% forecast, right, could be outperforming moving average by 20 percentage points, right? So then in situation like that, right, even if it is 60%, it's still pretty good. I think finally, I just want to give another alternative way of measuring accuracy. Again, this can be use case specific. So this is a real use case. This is done for one of the largest FMCG producers in the world, in Delhi. So this use case is actually from Delhi. They're globally one of the largest. And the objective was to identify retailers who are likely to underperform in the future, right? So that corrective interventions can be made proactively, right? Because see, if we really look at this, right? I mean, right? If you're into sales and things like that, right? We always look at our dashboards and right, we in hindsight, right, we know, okay, who has done well, who has done bad, right, which distributor has performed well, which distributor has not performed so well, right, or which SKU has done well, which SKU has not done well, right? But the idea is if we can actually get to know about it, right, in advance, right, the distributor who are likely to underperform over the next 3 months, we can actually intervene proactively, right? And that can obviously give a massive revenue boost to the organization. So that was the idea. So basically here we got a forecast for the next 3 months, right? And then we basically classified them, right, based on the forecast who's going to underperform and who's not going to underperform, right? And then with real data, right, once we have the real sales figures, right, we can actually with the real data also we can classify them, right? So who has underperformed and who has not. And now we have this matrix, right, where, right, so as an example, right, so this group, right, so so there are about 13,000 about 15,000 retailers here. If you look at, right, if you look at this group, right, so these are the 981 and 9,891, right? And that is actually 10,872. So a total of 10,872 retailers have underperformed. And out of that, the model has predicted that correctly predicted 9,891, right? So which means, right, with 91% accuracy, the model has been able to predict who's going to underperform, right? So this is an alternative way of evaluating your forecasting method. So it's very, very use case driven. The deviation based accuracy I talked initially, it basically it's very, very basic way of evaluating the accuracy, but there can be more relevant, right, more interpretable ways of validating our models. So these are very, very good example, right? So the deviation based accuracy for this particular example was at the retailer level, it was around 65%, right? But when we really apply that model to the real use case, right, it actually performs much, much better. So sometimes, right, we have to be very, very careful about the way that we validate some of these forecasting models. Okay, so I have a quick question. If SKU level forecasting is not needed, how is that the forecasting is going to help us in planning the production? I'm not 100% sure if I understand this question well. What I mean is, in that particular example I gave, right? So we need to figure out the total raw material consumption, right? Because that's the use case, right? So you can forecast the raw material consumption in total. We don't have to do SKU level forecasting, right? But of course, there can be other use cases where SKU-wise forecasting is needed, right? So it depends on the use case, right? I'm not saying that SKU-wise forecasting is not needed. It's absolutely the other way around, right? There are lots of use cases where SKU-wise forecasting is absolutely needed. But for that particular use case, I mentioned for raw material RM ordering, raw material SKU-wise forecasting may not be required. Asangi, do you think we can? So we have I don't think we have too much time for a demo. I think I'll just just provide a glimpse of Forecast Square, the product that we have developed over the last couple of years, which is used by quite a few companies in Sri Lanka as well as in the Southeast Asian markets. I'll just spend less than 5 minutes to provide you a quick glimpse of that, and then we'll take some questions. Okay, so this is Forecast Squad. I'm using, all you need is basically a browser. Everything is on the cloud. We are using Azure cloud. So let me just quickly select an organization and just show you maybe very, very few things. Right. So here, the data set we have, right, it's sort of a demand planning data set. The use case is actually demand planning. So this is an online grocery retailer based in India. They are one of the largest in India, one of the top five. So what we're trying to forecast is the number of carts, right? Number of carts is essentially means number of orders, um, and and this is a daily level forecasting that we are trying to do. So the frequency is at the daily level because the use case is they want to plan their operations, especially their delivery. How many riders that they need, right? That sort of a thing. So they need to have a daily level forecasting, right? So they can plan it in advance. So this is what we're trying to forecast, and these are the predictors, right? So I think we talked a lot about the predictors. So here we are using their digital spend, their traditional media spend, promotions, right? These are online promotions like right cashbacks and things like that. Uh, Discount amount per cart, right? So again, right? So discounts. We've taken some competitor, right? So Amazon is one of the largest competitors. So these are price competitiveness index with respect to Amazon, right? So these are the predictors that we've used. To use the product, it's super simple. I'll just open the same data set, right? All you have to do is, right, so you can see that, so they want to do a forecast here in this example for 15 cities, right? So we are trying to build 15 custom forecasts, right? So all we have to do is, right, just select the forecast that we want to get and just hit the train button. And that's absolutely it. All the hard work happens in the back end. As I said, there is a AutoML layer in the back. So we basically do everything that a data scientist will do, right? We will look at data, we will look at the outliers, we'll look at the anomalies, we'll do we'll do all of that data pre-processing. Yeah, and then right, we will consider, as I said, right, about 2,000 candidate algorithms, right? So these candidate algorithms, there are there are all kinds of algorithms, from machine learning algorithms to deep learning algorithms, all of that. And then we basically, within the algorithm itself, we will select the best one, right? So if we do this for two different cities, right, you might end up getting, two different algorithms. You might not get the same algorithm. And and that is how it should be in forecasting because, right, as I said, there's no silver bullet algorithm that works for everything, right? So that is kind of necessary. So since we have built this AutoML layer, right, I think we can solve this uh, uh, accuracy and scalability paradox, right? So since it's all of that is done automatically, right, we can do hundreds of thousands of forecasts without compromising on the accuracy, right? So training this model will take 2 to 3 minutes, right? So it might take a little bit long because it has to go through all of these different algorithms. Um, and so so I think I'll stop this presentation. So there are lots of features in the product where you right where you can set your predictors, right, based on your future plans, right, which is very important, right? Let's say, as an example, if marketing is one of your predictors, your marketing plan, your marketing budget, if you can incorporate that in it to your forecast, you will get a more accurate forecast. And whenever you change that, your forecast can automatically change based on that. So it's very important to set your predictors. You can automatically validate your forecast. If I just go to a similar data set, but here I have already trained my algorithms. I think I have time only to show this feature. So here I have built models. I have done my forecasting on 5th of February, right? But post doing forecast, I have appended more data into the system, right? Since we are in May, right? So I have more data into the system. So once I have more data in the system, right, I can compare my forecast against the actual numbers, right? So you can see here, right? So you can see this color. It's different from rest of the models, right? Which means once I appended data, my model has actually underperformed, right? So all of these have performed as expected, right? So because once I append my data, I can compare my forecast against the actuals, right? So I will know, right? So here this model hasn't done too well, so I can actually recalibrate this model, right, based on my append data. So of course, I don't have time to go through all the features. We'll take maybe 5 minutes of questions, right? And then we'll conclude the session. I'll stop sharing my screen. We can, Asangi, if you can raise your hand, I think Asangi can unmute, and please keep it short.
Thanks, Anka. If anyone has any questions, they can type it in or raise their hands and I will unmute yours so you can ask your questions. We have a few questions coming in. I'll pass them on to Sanka.
Okay, what would be the ideal data volume? Okay, the simple answer would be if you are doing monthly frequency forecasting, ideal would be 3 years, but 2 years could be sufficient, but ideal would be 3 years. If you are doing daily sort of forecasting, maybe 1.5 years could be sufficient. 2 years is the ideal. Yeah, I think there is a question. Asangi, there's someone who has raised hand. Can you unmute that person?
Suhail, you can unmute yourself. Hi, Suhail. You can unmute yourself and ask the question. Okay, I think Suhail doesn't have any more questions for us.
Fauzan has a question, Asangi.
Yes, hold on a second. Hassan, I'm having trouble unmuting you. Is it possible for you to type in your question? I'm really sorry about this. Okay, Fauzan, I've allowed you to unmute yourself. You may go ahead and speak.
Okay, thanks, Asangi. Am I audible?
Yes, you are.
Yeah, so thanks, Anka. It was a crystal clear presentation. We were able to get a lot of knowledge and not lot of what do you call areas that we never thought that they are there. But so thanks for taking us on those avenues. My question is, the earlier question from me was regarding the ideal historical period to have do a successful forecasting. But what if I must start a business and still want to do a forecasting, but still do not possess enough data to do a successful forecasting? What would you recommend me? Like, should I stop forecasting for 3 years and to continue from next? I mean, if I am to get successful predictions, or else is there any alternative method that I can practice? Something like a formula or something to generate
Right.
from them.
Right. So you should of course you should not stop. So you should start with basic methods and then gradually move into a little bit more sophisticated methods. Um, so that would be the way forward. But definitely, right, you should, you know, definitely you should from day one. I think it's important that you keep this objective in your mind that, you know, you want to do this, you know, you want to use your data, right, as soon as possible. So you should be able to, you should, you know, collect that data, right, in a way that, in the right way. So from day one, I think, you know, all the new businesses, right, these days, right, like what they say is, right, every business is a data business, right, in this, right, in this day and age. So I think you should think of your business as a data business from day one. Collect that data, right, in the right way. But you can, as I said, you can start with some basic forecasting, you know, approaches and gradually move on to maybe more complicated ones.
Okay, thank you very much. Another challenge that me and my organization face is we have been practicing our business in few different systems. So there has been system migrations in each of those at some points of again of the timeline. So gradually we have left some data on one system when we move the balances to the other system. So of course there's going to be a problem for us when we are going to do a forecasting in terms of data consolidation. Are there any known tools or are there any known practices, best practices to follow in when we want to consolidate data, as in like uh, do you have any recommendations or tools in sort of which would address that challenge?
Yeah, I think yeah, I get this problem quite often, right? That you don't, we have, you know, migrated from one system to another, and as a result of it, we don't have data, or our data is no longer consistent, right? Uh,
Exactly.
so I think it's I think rather than risking inconsistent data, the the best way forward would be start with what you have. All right, start with data that you're certain of, and consistent. You know, rather than you know, because if you try to consolidate everything, right, that can actually do harm than good, right? Um, but I probably can't give you a very specific answer without really knowing what kind of data you have. But as a rule of thumb, right, you should work with the data that, you know, you trust and you're quite certain of.
Thank you very much. That makes sense. Thank you very much, Hasan.
No worries.
Asanka, we have another question. Dawal, you may ask your question now. Hello, Dawal, can you hear us? Dawal, you can unmute yourself and you can go ahead with your question. I think we may be having trouble hearing you. If you can type in the question on the chat, I will pass it on to Sanka. If there's anyone else who'd like to ask a question, please raise your hand and I will unmute you. Dawal, would you like to try asking the question again? You're unmuted, but we can't hear you. There must be some trouble with your laptop. Sorry, Dawal, we still can't hear you. If you could just type in question after question. You mentioned that you have 3 questions. Sanka will answer them.
Okay, until Dawal types, if anyone else has a question, you can just ask. I think everyone must be thinking about their lunch, right? Probably not thinking about forecasting anymore.
Okay, so while we wait for Dawal, I'd like to remind everybody of the BYOD party with Forecast Squared, which is bring your own data. I have shared 2 slides. I will share the information once again on the chat before we conclude. You can book a session with one of our data scientists and get a one-on-one learning session about how to do forecasting right using Forecast Squared. So we have Dawal's question. Sanka, I'll read it out. On one data set, Google AutoML, Microsoft Azure, and IBM Watson gives different, I think it's predictions. What would the best and how your forecast will help?
Yeah, I think we talked about how to evaluate these forecasts, right? So the basic way is to do sort of a deviation based accuracy comparison, right? So you have the forecast, right? And if you have some actual data for the period that you have forecasted, so you can do a deviation based comparison. You can calculate the deviation based accuracy for each of the model or for each of the forecasts, and based on that, maybe you can make a decision. But as I mentioned, deviation based accuracy, it's a very basic generic way of doing that. So if you can, right, maybe right, if your use case is slightly different, you can use some different ways as well. But I think a generic answer would be, yeah, you can compare them using deviation based accuracy.
At Sanka, I'm just going to read out Dawal's second question. How the dynamic situation of past 1 year will be taken care during forecasting for the next year?
Right. So that's a very I think that's a very relevant question. There are multiple approaches, right? First approach is you basically try to use some anomaly detection or smoothing techniques, right? And make sure that your forecast is not swayed by these normal observations. So as an example, in our product in Forecast Squared, we have this feature where you can, in your data set, you can basically define a period that has shown some abnormalities, right? We call it exemption periods. So once you define the exemption periods, what the algorithm does is it basically ignores those data points and basically tries to impute those data points with sort of a smoothed line. So when the model is trained, the actual data is not used. The imputed data is actually used. So your model algorithm training process or the forecasting process is not unduly influenced by those data points. That's one way of doing that. The second way is maybe there is a predictor, right, that we can bring in. We can bring in a predictor called, let's say, lockdown days, as an example. So if we have lockdown days as a predictor, the algorithm will try to correlate let's say the demand or the sales with this lockdown variable. And whenever this lockdown variable is there, right, it will basically handle the forecast accordingly. So basically what it does is it basically correlates, let's say, loss of sales to the lockdown variable, not to sort of a drop in demand. So by correlating it with a predictor, you can make sure your forecast does not suffer. So that's another way of doing that.
Right, Sanka, I'm going to read out Daval's third question. Is there any restriction in your product? Can it be used on trial basis like Google AutoML?
Yeah, we can. If you are willing to use the product, we can give you a trial version, and of course you can compare it with Google, Amazon, right? Other forecasting platforms as well. So yeah, so please reach out. We are happy to give you a trial version that you can try out.
Okay, Sanka, we have one more question from Heshini. I'll read it out. When adding more predictors, we also have to compromise with model complexity. Feature importance is one technique that helps. Can you suggest other methods? Okay, the question continues. My objective is finding most relevant predictors.
Right. So I think this is what I talked about, right? So it takes time to build a good forecasting, right? So you have to look at all of these features. You have to look at feature correlations, right? You have to be worried about right, overfitting, right, when you have large number of features. So that is why I think using some kind of AutoML, right, algorithm helps, right, where you can do all of this algorithmically, right? So in terms of as an answer to your question, how do you? I think it's very important. Just don't take a very mathematical approach. Take a domain approach as well, right? Certain things are. So as an example, if you have price as a predictor, right, you should not have discount as a predictor, right? It does, right? Just doesn't make sense because, right, both things are correlated with each other. So by using some domain, right, experience, try to reduce your feature set. That's one thing. The other thing is try to use an algorithm which does this feature elimination automatically, right? That's the other way, because typically what happens is when there are lots of features, lots of them are correlated with each other, so they're essentially saying the same thing. So use algorithm which exclude these features automatically.
Thanks, Anka. We have one more question from Johan. Is your tool could be integrated with other ERP systems, example SAP? If yes, is it live data transferring?
Right. So right now we integrate, our system can be integrated with any database because we are using Azure Data Factory. It's not real time, it's near real time. It's the way that you configure the sync-in process. But for forecasting, I think a near real time sort of data syncing is enough. So that is what we've done. But we can do a stream integration if needed. But for most of the cases, a data stream integration is not needed.
Thanks, Anka. I think that's it in terms of the time that we have today. If anyone wants to clarify any more, any questions, any queries that you all have, you can write to us via info@linearsquare.com.